So today what I'm going to be talking about is like benefits of isolation from containers and how containers help security overall. So first things to get out of the way are containers aren't going to be like the answer to preventing your application from being compromised. Like there's no way that they're going to do that, but they will limit the damage of a compromise if it occurs. And the world that like an attacker might see from inside a container with a very strict custom Seccomp profile and AppArmor profile is going to be a lot different than what it would be were it running on your host and such. And I'll prove that in a few various ways. Containers today, if you're not aware, it's made up of a lot of just things built into the kernel. So there's namespaces, cgroups, AppArmor, SELinux, capabilities, and right now they're run as root, but I'll get into later some advances in that realm and why that is. And I'm also going to go over what each of these are. So everybody knows kind of like that containers exist, but a lot of people don't realize what actually is brought together to create this thing that we call a container, because on its own, like a container is not a thing. It's actually just a group of Linux namespaces and control groups applied to a process. It's not a thing on itself. It's not like a Tupperware container. So control groups or cgroups limit what a process can use, whereas namespaces, on the other hand, limit what a process can see. First, to go over control groups, there's a lot of different kinds. There's memory, CPU, block I/O, blah, blah, blah. The memory cgroup limits what can be used for like physical memory, kernel memory, all that. You can get notifications, which are out-of-memory notifications, and you can keep track of what is being used. Cgroups also exposes some statistics as to what is being used too, which is really cool. So for each of these cgroups, you can limit what's being used and then also track what is actually being consumed. The CPU cgroup allows you to track CPU time, usage, and you can also pin to a specific CPU on a machine, which is pretty neat. Block I/O keeps track of I/Os for each group and device. You can set throttle limits, bandwidth limits, and set weights. This is kind of like a short demo of another cgroup, which is the PID cgroup. This was just recently added into the kernel. But all the cgroups are, controlled by files, and they're in like sysfs cgroup primarily. So what we're doing is setting the maximum amount of PIDs to 2, and the current PIDs is 2, so what I'm going to try to do is launch another process, and we're going to see that it fails. I know it fails because I already did this, and this is not a live demo. So it's like it cannot fork another process, which is great. So you can actually prevent a fork bomb with cgroups. Yay. And that's super cool. Namespaces limit what the process can see. So just a reminder, cgroups limit what a process can use. So there's a bunch of different kinds of these too, and some of the names overlap, which is confusing. There are files in proc, PID, NS, because Unix systems, files, yes. When the last process in a namespace dies, the namespace is cleaned up, which is super nice. And you can re-enter a namespace with nsenter. It's a part of Linux utils that you can probably download through your package manager. Mount namespaces basically get its own rootfs, which is where, if you're familiar with Docker, the container image is, what's placed in the mount namespace. And you can mask things like proc and sys. Net namespace get their own network interfaces, so you have your own local interface, you have your own and you can have your own like IP tables chains, stuff like that. And here's kind of a demo of doing that. One of the cool like Linux command line utilities is unshare, and it allows you to create like namespaces on the fly. and you can kind of determine whichever ones you want. So this is like all these network interfaces that I have on my host. And then if we run the same command in a network namespace, if I just unshare net, there will only be one, which is kind of the entire point of a network namespace. So UTS namespace is for hostname isolation. So there's another demo of that one. Like on my host, the UTS namespace is going to be my actual host name. And then if I run it in a container and actually try to change it, it will not actually change the one on my host, which is great. And if you notice, like all these unshares, I'm having to run with sudo, which is such a pain in the ass. But there's good things coming that will allow that not to be a thing anymore. So cool. I changed it on in the container. It's a thing, but my host name's still the same. IPC namespace is for like message queue shared memory isolation. So another one of these. We can like create a message on my host and then make sure that it's not visible from inside a container and vice versa. Docker also allows you to, configure each of your namespaces and cgroups, which is cool. And it's not in the container, so yay. PID namespace is just processes and what can be seen. You can nest PID namespaces. Chrome actually uses PID namespaces per tab, which is cool. So you can have a PID namespace and a PID namespace. You can do the same thing with containers. It's really actually not that cool. So if we get our PID on the host, then we can get the PID in a PID namespace. This is why all containers run processes as PID1, because they're in a PID namespace. You can also run Docker containers as, you can set like PID host, which is cool for doing things like strace in a container. You could have like a sidecar container that just runs strace. But yeah, so the first time you do this, you're like, why in this container was it not PID1? You actually need to remount proc so that not all of proc is there, because obviously if all proc is there, then you can see all the processes. So if you run unshare then with proc remounted, you'll actually be PID1, which is a common misconception that people just think that it will work out of the box. Docker does this obviously by default. And cool. So user namespaces are interesting. There's a lot of like kind of vulnerabilities that come about with creating a user namespace and then escalating your privileges from there, because there's a lot of code paths that just are not great that you can wind up in that allow you to do that. So actually what Docker does by default is uses our Seccomp profile, which I'll get into later, to block creating user namespaces when you're already inside a container. But you can use Docker to have containers run in user namespaces, which is different. And you can map a UID and GID to different users on the host. So UID 0 inside a namespace can be mapped to like some huge UID on the host, which is really cool. So you think that you're root, but you're not really. So if I like look at some files on my host, like you can see that they're owned by Jesse, which is myself. And if I run in a user namespace, and this is the only one that doesn't need sudo. This is why so many problems occur. You can create user namespaces as an unprivileged user and then escalate your privileges from there if you use a certain vulnerabilities. There's a lot of them. So then I'm nobody, which is cool, because nobody even knows what that UID is. Okay, so that's kind of like the main like infrastructure of containers itself, and I kind of just blew right through it because it's just a lot of things that have been in Linux forever, and you can always like go look up what it is later. But what's nice about Docker is that it actually has same defaults for like LSMs, AppArmor, SELinux, Seccomp. And we tried to have like a same default for that and then also make it customizable to the user and their specific application. Of course, nobody customizes it though because nobody wants to write these profiles, but that's a whole nother problem. So yeah, by default, we block things like writing to proc number and proc sys. We block things like mount, and we block writing to sys, and you can run any sort of custom profiles per container. And like a huge common misconception here is that like this is like some sort of magical savior. I like hang out randomly in the AppArmor IRC channel, and sometimes they'll ping me and be like, someone came on the mailing list and asked a Docker question. I'm like, oh shit, I hope I know the answer. But so one of them that came up was that, you know, somebody was using SELinux at the time, and they were told by Red Hat, I guess, that if someone were to break out of a container, that SELinux would still protect them. And I'm like, I mean, I really wanted to reply, like, what Kool-Aid are you drinking? Because if you've escalated your privileges out of a container and broken out, like, there's really not much an LSM can do to save you at that point. But I basically explained that, like, the goal of LSM support in Docker is to minimize the possibility of a breakout. There's not much we can do after someone has broken out, which is why we block all these things that had, you know, previous vulnerabilities. And like another main problem is that like no one wants to write custom AppArmor profiles. I mean, I hated maintaining the Docker default one. I did not want to do that. It's still awful. Like I answered that email like 4 days ago, and I don't even work for Docker anymore. So AppArmor is pretty just insane. The syntax is horrible. The regexes for files and stuff, it's horrible. So that's why we kind of try to have same defaults, but it would be really great if people wrote custom profiles for their apps, because that's where you're gonna run into greater isolation. So a tool I made that stemmed from someone on the Docker security team when I was working there at the time asked me to write them like a custom AppArmor profile for their talk, and I was like, no. I mean, I'm not going to do that for you. I wouldn't even do that for myself, honestly, because it's just no fun. But then I was like, we could probably easily generate this, because obviously there's a syntax for AppArmor, and then we could use something way better and generate a profile from that. So I made this tool that basically does that, and it expands on Docker's same default. So it takes that one and then just adds more things to it so that it's more secure. Here's kind of an example of how it works. So you have like this TOML file, which is this hipster configuration language. And you know, it has a name, and then it has like all these paths that we want to be read-only, and then it converts it over to, on the right, the AppArmor profile here, which like just look at how gross that is. And then you can do like log on write paths, audit those, and then it basically converts all these, you know, rules into something that is AppArmor capable, but it's not ugly like AppArmor's syntax, which is cool. So you can get a lot more isolation this way, and you know, really, really contain your apps. And in that repo, I have this sample one for Nginx, which I think is pretty good. Seccomp. So Seccomp is new to Docker since like last November. I added the support for this literally on the night before a conference talk at DockerCon, but then it wasn't merged until later. So Docker has a default whitelist, which we took a lot of time with, and I went through like old kernel mailing lists, stuff like that. Anything that was questionable was removed from the whitelist. So it's a really good default. Red Hat was even trying to like add things to our default whitelist. And I was like, no, I mean, we already have it secure. So in their fork, they actually added things back, which is good to know. One of them is unshare, which is interesting. Not what I would have done or agreed with at all. Actually super opposed to that. So my opinions on things. It prevents things like cloning a user namespace inside a container, which is one of the things Red Hat added back, which is super questionable. And that's, like I said, a weak spot for kernel vulnerabilities. And you can also like make custom profiles as well, which is super cool. But also no one will do, because I don't know if you've ever like looked at a Seccomp like rules before, but it's no fun, just like AppArmor. None of these things are fun. This is why nobody uses them. But it is really good to have sane defaults. So we also keep track of things that like are non-events. I got this idea from, of course I'm forgetting the name now. There's another application that does this too, which is super cool. But any sort of vulnerability that like Docker was already protected against are listed here. And it's just a lot of things like, you know, privilege escalation from user namespaces, mount calls, stuff like that. Anything that we are blocking by default, we just add here, which is cool. So I kind of went over like the state of everything now, but as you can see, it's not perfect. Obviously, no one will write custom profiles for AppArmor. Nobody will write them for Seccomp, and they should, because that's where you really block what an attacker can see inside a container and what they can use. So there's a few ways to go about making this better. And like I said, this is the state of containers today with the really sad one on the bottom. And like, so the reason that containers, or at least like the way Docker creates containers, needs to be run as root is because cgroups, to write to like sys fs cgroup and create those files, you need to be run as root. Literally everything else in this list you can do not as root with the capabilities from user namespaces not having to be run as sudo, which is great. So I made a proof of concept where you can basically do everything except the parts of cgroups that are run as root, since that's not possible today, where you can create containers as a non-root user. And that's kind of what this proof of concept is. It also stores the rootfs inside the binary because I'm absolutely an insane person, so that's why it's just called Alpine. So if you look at like the UID map and GID map inside this container, or inside this container that I didn't run as root, it's a different user. And I have all these namespaces, all the ones I mentioned previously, and that's super cool. You can also run other images with it. So this one's Debian. And you can try to do crazy things like unshare inside it, but of course the default, profiles that I enabled with this won't work. So this is super cool, and it would then mean that you can run Docker without being a sudo user. You could run the daemon without being a sudo user, which is great. We could actually have like that Docker user on your host, not have every single privilege in the world. But like it leaves open the question of what are we going to do about cgroups, because you do have to be a root user for that. You can't even chown the files to a different user and then create them. It doesn't work. So user namespaces can be created without root, but only if the UID GID map is mapped to your current user. So those containers are running as me. They thought they were root, but technically they're me because of user namespaces. And it's not perfect yet because, of course, you need capsysadmin for cgroups. But the cgroups namespace was introduced recently, which we thought, like when we were reading the changelog for the kernel, that this was going to be like our answer for everything, but it's not. It actually works pretty differently, and only because, like I said, namespaces, limit what a user can see. It really just limits what cgroups you can see, which is really shitty. And I really just wanted to be able to create cgroups as a different user. But there are patches being made to the kernel to allow that to be enabled. So sometime in the future, this will be possible if you're running like the latest kernel. But just to show kind of how a cgroup namespace works. It is still cool for what it is, but it's just like not what I wanted it to be. And as long as you're creating like user namespaces at the same time you're creating all these other namespaces, you don't need to be sudo, which is why like that whole thing works, which is cool. So this is why also unshare is awesome, because you can just create all these namespaces on the fly like that in this horrible one-line bash script. So now that we're in here, running just a shell, you can check out that the UID map is, this 0 means 0 in the container. 1,000 means that my actual user on the host was 1,000, and that's what it was. Same with the GID map. And now that we're in the container, we can, create cgroups. The problem is that we really needed to create them previously outside the container too. And if we even try to make the hierarchy and mount something, there's also 2 cgroup APIs, which is why that's cgroup 2. There's just a lot of intricacies to this that are hard to get into. You mount those files as a cgroup file system. And then, yeah. The cool thing about cgroups is it is all just files. I mean, that's the cool thing about Unix systems in general. So you can just change these things at the command line, which is why all those people oh, I can do Docker and Bash. Like, you really can, but it just won't work as well because you won't get, unless they do all the things like AppArmor, Seccomp, all that in Bash too, which is highly doubtful, you won't get the same type of protections. So, as you can see, we can't create the cgroup subcontrol file, and automatically we can't do the things I want to do, which sucks. So what to look forward to in the future of containers? Like right now, they are at a good place, and if you've read like the NCC Trust group paper on containers, they overall say you should be using containers because you're better off with them than you are without, and I totally agree with that sentiment. You are. Like if you're running your apps on your host, you're way better off using a container than you are just with that. But if you're I want to run this app in this VM and use VMs as isolation, yeah, sure, that's going to provide you a lot better isolation than containers will ever be able to, just because containers share a kernel, obviously, and VMs do not. So containers in a multi-tenant environment in the future will not run as root, which is cool. Once those patches are merged into the kernel, and then we fix things in Docker itself. And you'll get still the same thing with Docker as sane defaults, but you should, really customize your LSM control from there. And Docker makes it easy-ish to do, like I showed with the tools for generating AppArmor profiles and stuff like that. Better designed user experience for security policies too. I really wanted to do that, but I don't work at Docker anymore, and I don't think anyone there is working on it, so that might not actually happen. There is a thread on the Docker repo, if anyone is so interested to go check that out about that, but I do not know if anyone's assigned to that. So that's the link to the thread about it. There's also the link to the NCC group trust, and I'll post these slides later. Sysdig Falco is actually really cool. It does kind of you can create rules for how containers should behave and stuff like that. I think they've done like a cool job with the user experience of it overall. There are like some random things that I'm working on for fun. If you are a user of Go, I have like some fake patches to like add to the build tool chain of Go, automatically generating of Seccomp profiles, since we basically will know what syscalls you're going to use because of like the way the programming language works. So I have this like crazy idea to create kind of isolation through that, but it's more like a pipe dream, but it will be like a thing. I just don't think it will be added to Go, but it is kind of neat in that. So that's basically about it, and we can just do questions if you all have any, because that was a lot of information. Yeah.
So we say, well, I understand a lot of this is based on Docker stuff. Again, as a LXC user, like, is it even portable to that? You say like, a lot of the containers run as root, but you can run containers.
It's all the same thing, except for LXC doesn't have defaults like we do, or Docker does. But yeah, they all use the same primitives. They all use, I mean, because a container is namespaces, cgroups, AppArmor and SELinux, all that stuff. Yeah.
Is there another part of the kernel you'd like to see namespace? Like, are there still settable things that you wish to be constrained?
Time would be really cool. When you change time inside a container, it changes it on the host, but you obviously need the privileges to be able to do that. But it would be cool to have containers testing various things in different times and also modifying the time without modifying like literally the rest of your computer. That's about the only one probably. Yeah. Yeah, it's part of their fork that if you like download Docker on their distribution, you'll get their fork by default. So you get less containment. And it really sucks actually because it's somewhat ironic coming from Red Hat. I think that they pull those. Yeah, they probably do. Yeah. Yes.
You say that you started the fire for container security?
Started the fire. I don't know. I don't know if I can take that as a. I think that like Aaron's paper on container security is great, and he also highlights the same tool that I showed you. That's cool. Anything else? You can also use like AppArmor, SELinux, SELinux, Seccomp, all those, like with Kubernetes too, obviously, since it all uses the same stuff at the end of the day. Cool. Is anybody running containers right now? Nice. Are you using Docker? Cool. Nice. Does anyone write their own custom profiles for things? No. Yeah, that's what I thought. It's so bad. I mean, I don't know. I've written a lot of AppArmor profiles, and I would not do it again.
It sounds awful, but I used to do AppArmor profiles before I had Docker. And once I got Docker, I stopped. Now I just
Yeah, I mean, the default is really good. It's just, yeah, totally. Cool. Okay. Thanks.